Hey everybody, this is Bob Crossan, Senior Managing Editor for Water and Waste Digest. Today I have another top project interview for you, and with me today are Tony Schachle, he's the Chief Engineer for the Water and Wastewater Department for Riviera Utilities, and I have Lee Kibbler, he is a Engineer for Riviera Utilities, and they're going to be talking about the project that they got a top project for in 2021. So thank you all both for being on the call. I really appreciate you guys taking the time, and congratulations also on a top project.
Awesome. Thank you.
Thank you, Bob. Good to be here.
So I wanted to start first by getting an understanding of the area that you guys serve. Could you describe the community that this project serves and kind of the reasoning behind this project in the first place?
Yeah, sure. I'll be glad to take that one. We serve the city of Foley, Alabama. We are in South Baldwin County in Southwest Alabama. We are about 20 miles or so from the coast, from the Gulf of Mexico. We are predominantly a residential community, although we have a fair amount of commercial and some light industrial use. This is one of the fastest growing areas in the state of Alabama currently here in South Baldwin County and including the Eastern Shore area of Mobile Bay. And so we're seeing exponential growth in the area. And so that is put some pressure on obviously our wastewater treatment collection and treatment facilities. Certainly this project was needed in order to meet those capacity requirements going into the future.
Yeah. So could you describe kind of what was the size and scale of this? What aspects did you have to complete to make this project a reality?
Okay, I'll take that one. We were prior to this, we were looking at a 2 million gallon plant that we were running at about 1.6 to 1.8 with the 2 million, 3.5 million gallon peak. And we just were running into situations where we were running out of capacity. So we looked at an incremental capacity increase to 3.5 million gallons per day with a 6 million gallon peak.
Yeah. I mean, it's a huge shift, it seems like, in terms of your capacity. What types of things did you have to think about when you were looking at getting to that level? Like, did this require added workforce, for example? Like, what other elements were you thinking about when it came to this thing being completed? What's next, essentially?
Well, the biggest problem we ran into the is we were at a position where we had a small area to install incremental capacity increase. And also the state of Alabama was adding monitoring for nutrients. So the big problem we were looking at is how do we invest in our utility and protect our ratepayers facing potential nutrient changes? We could have easily just added another oxidation ditch and continued on down the road and just added chemical in the future, but that would have resulted in a lot of chemical addition and probably not been the best utilization of our company's resources as far as financial. So we went out and started looking for different technologies that we could utilize in trying to add nutrient removal in a small footprint.
Yeah. What was also out of a curiosity of mine that I've been asking all the top projects this year, what was the project delivery method? I've heard all different ones, but I'm curious what you guys ended up going with for this one and why.
So we used a design bid build
Okay.
method for this project. And we really felt like with the AGS process being a new process in the United States, certainly wanting to make sure that we had fully vetted all the design criteria and options for that. This was a new emerging technology for the folks that were supplying the equipment, like Aqua Narita, for the engineers that were helping us, like Goodwood Mills and Kaywood. And so we wanted to make sure that those design elements had been fully vetted during the design process before we went to bid, so that we knew when we got to bid date that the cost that we obtained as the low bidder on the project was going to be essentially the true cost of the project. And we felt like it was going to give us a more economical project at the end of the day. So.
Yeah, yeah. Well, that it's really interesting because I've heard all SWATs. I've heard design build for a couple of them. There have been some progressive ones as well, but design bid build still seems to be holding pretty strong for a lot of utilities out there. So it's just like a personal curiosity of mine that I'm really trying to understand a little bit more. But good to hear that it worked out well for you. Wanted to step more into like kind of some of the project challenges. One of the core ones there was the discharge to Wolf Creek and some of the challenges that poses to your facility. Could you talk about those difficulties there? What are the challenges of discharging to Wolf Creek, and how were you able to overcome those with this project? I'll start with Lee.
Go ahead. Go ahead.
Go ahead, Lee.
The challenges for discharging the Wolf Creek are, sorry, we've got a little bit of construction going on.
Yeah, no problem. You got work you're doing.
The challenges, Wolf Creek is actually Wolf Bay is an Alabama outstanding waterway in the state of Alabama. It's one of two outstanding waterways, one being Cahaba and the other being Wolf Bay. Wolf Creek discharges directly into Wolf Bay. So that is one of the primary reasons we believe that this is going to be a nutrient target for the state of Alabama, because it's a pristine waterway. So our increasing capacity of discharge into this waterway should lead to, in the future, increased nutrient limit constraints. And every time, like the other in Alabama, the Cahaba River is the other one, and they have some of the tightest phosphorus limits in the country, into that watershed. So 1 + 1 = 2 in this case. So we need to protect our utility from potential rate increases.
Yeah, those phosphorus limits, I like here in Illinois, from a lot of the folks that I've talked to on the wastewater side, it's not quite there yet, but they know it's coming. So all of them are really trying to prepare for the exact kind of challenge that you were dealing with here. How do you guys aim to address this during design and construction with this project?
Yes, what we did is, we selected an advanced nutrient removal process to begin with so that we could target biological nutrient removal. We did not install any phosphorus measurement devices because we are still on monitor, but our process is still capable of removing phosphorus probably down to 0.7 ppm or lower as a biological process. Right now, we're seeing typical numbers of less than 1 as we're running today, without any PO4 measurement devices or optimization. So, we also added filters into our design so that we could polish our water before it goes through UV to prevent us from passing on pathogens that are shadowed by TSS going through the UV system, providing us a beneficial reuse water for our wastewater plant, and 3, protecting us in the future for biological removal to remove the physical TSS that could carry phosphorus into the environment. We also added a coagulation tank into our process train. It's not fitted out for chemical addition at this time, but we chose to add the tankage because of the value of scale that we would get during construction of a project of this magnitude.
Yeah. So I know, Tony, you had mentioned this earlier on in the questioning about the AGS system, the anaerobic granular sludge. Could you talk a little bit about what led you guys to AGS for this project?
Yeah, certainly. There were several reasons that AGS was ultimately selected as the process for this expansion. As we've alluded to, I think throughout this, we're limited on the area that we have in the current footprint of the wastewater treatment plant. The old system that we had was an oxidation ditch, actually 2 oxidation ditch trains, and we were left with what was left of the property other than those 2 trains as the area for this expansion. And so in looking at not only enhanced nutrient removal and increasing capacity to meet, projection demand, population projection demands, those kind of things, we also wanted to make sure that we essentially got the most bang for our buck for our ratepayers in that we could get the most treatment in the smallest footprint possible. And AGS allowed us to do that because of the high mixed liquor, volatile suspended solids concentrations, the high settlability of the AGS, and some other factors. We essentially doubled our treatment capacity from 2 million gallons a day to 4 million gallons a day in a third of the footprint. So what that is now allowing us to do in the future, as the capacity needs increase, we could replicate this exact treatment train 2 additional times on our current property by replacing in the locations where the old oxidation ditches were located. So essentially what we could end up with theoretically is a treatment capacity of up to 10 to 12 million gallons a day from this one site, which we would have probably been limited to something more like 4 or 5 MGD with a more traditional activated sludge process. So we feel like this has set us up for the future and future expansion as needed. Now, whether or not, one of the concerns about discharging to Wolf Creek, will the Alabama Department of Environmental Management allow us to discharge 12 million gallons a day into Wolf Creek? That's another question. But we certainly have put ourselves in a position to be able to do that.
Yeah, Mike, what an advantage to be able to to do all of that with such a smaller space, and knowing the concerns that other utilities around the country have about the size of their space. This could be a really, really big game changer for a lot of them too. Had you used this type of technology prior to this, or was this kind of like a first go with it, and you guys were just so impressed with it that it seemed like the perfect fit given the size constraints that you were talking about, and then the expansion?
Well, we looked at lots of different processes prior to doing this particular process, but the energy savings, nobody in the United States had any experience with this. This is the first one in the United States.
Okay.
The engineering firm that we dealt with built a small pilot plant at Rockford wastewater treatment plant in Illinois. But that was a very, very small train. This is the first full scale unit in the United States. However, in South America, there's at Rio de Janeiro for the Olympics, this particular process was selected. And there are this process is all over Europe, and Australia is starting to move rapidly through Southeast Asia and being adopted virtually all over the world at this point. It's very rapid growth now that somebody has adopted the technology in this country. But in premise, it is a attached growth process similar to like MBBR with the little plastic carrier. However, there's no carrier. The granular sludge builds upon itself. So it's a lot of disadvantages with MBBRs where you have to use screens to keep the carriers in the tank. You don't have to deal with that with this process. So it's very robust, very energy efficient, and you get nutrient removal. What else could you ask for? So, I mean, in principle, we had a lot of anxiety about selecting this technology because you just can't go down the street and see it. But with a company like Royal Haskins and Aqua Aerobics behind it, Royal Haskins was behind the orbital train design back in 20 years ago, and everybody uses orbitals now. So this technology was well vetted, so it was actually pretty low risk as far as. But it didn't take away the anxiety. I can tell you that.
One of the things I wanted to ask you about too was in the nomination form for this project, one of the challenges that was mentioned was the fine grit and sand. Could you explain why that was an issue in terms of a challenge and what you did to get over that hump?
Yeah, I'll start. I'll let Lee jump in as well on this one. For us, being located where we are, roughly 15, 20 miles from the coast, we're in an environment where we have lots of sand. And so our sewer collection system, gravity collection system, and lift stations, we have a lot of issue with sand getting into those systems, which eventually end up at the wastewater treatment plant, especially during heavy rains. And we tend to have those down here, one of the rainiest areas probably in the country, and we're susceptible to hurricanes and tropical storms and those type of things too. So we historically have had a lot of sand and grit in the wastewater treatment plant back when we operated the oxidation ditch process. But we really didn't have a good method for removal. Then we just kind of dealt with it in the oxidation ditch. But we knew going into this project with the AGS process, with these reactors designed the way that they are with fine bubble diffusers and all the equipment and piping and those kind of things that are in those tanks, it was going to be something that was important not only to the AGS treatment process, but also long-term maintenance of those tanks. So having to drain that tank, clean grit out of them, those kind of things would have been an issue for us. So we, as part of this project, upgraded our headworks, or completely replaced our headworks, and added rotary drum screens for solids removal, and then a grit removal system to remove as much grit and sand out of that influent as possible. And we sort of say it works. I think Lee would agree. We fill up those dumpsters rather rapidly during rain events in removing sand and grit. So it's doing the job we intended it to do. So.
Yeah.
Our grit is really challenging down here. It's a quartz type grit. It's really, really fine. And if you go to Lowe's or Home Depot and you get sandpaper, the stuff that's on that paper is coming into our plant. It's a really hard quartz. So it's not like a volcanic or a silt. It's really it really, really wears on equipment. And the other thing with the Nareda train, there is no free lunch. So if you concentrate the mixed liquor and you make it much higher, say an 8 grams per liter in a tank, so you're going to also concentrate the amount of grit. So it's going to build up a lot quicker in a smaller volume tank. So yeah, the investment in a grit removal system for this process is a non-negotiable.
Yeah, it sounds like it. That sounds awful to deal with.
It is. It's horrible.
Yeah. Well, and being near the coast, like you said, Tony, like storm events and stuff, you might get a huge wash of that, and you just have to be prepared to handle it. So I'm glad that this helped address that problem in particular.
Right.
Yeah. Well, before I let you go, I wanted to get some shout outs from you. Obviously, this just the two of you on this call, but so many more people were involved in this project, and I wanted to give an opportunity for you guys to recognize some of those folks. So, Tony, I'll start with you. Any shout outs that you wanna provide for the folks who helped out with this project?
Yeah, sure, absolutely. I'd like to start with our board of directors and managers here at Riviera Utilities who bought into this project, with it being new and emerging technology in the U.S. Putting yourself out there to be serial number one on something like this is not always an easy thing to do. But the board was very supportive, management extremely supportive as well of this effort, and so great thanks to them. I'd also like to thank Lee as well. He was very instrumental in researching this process. He was actually instrumental in making the connection between aqua aerobics and Narita in order to for them to market that product in this process here in the United States. So he put in tons of time and effort into the research and the planning so that when we got to the design phase, it wasn't we were not starting from ground zero and starting from scratch. We had some good information to base that on. Obviously, Goodwin Mills and Kaywood, or GMC, was our engineer. They did a tremendous job with this being a new process as well. From their design folks to their construction inspection department, they did, I feel like, an excellent job overall for us. Max Foot Construction was the contractor. Again, we had a really good general contractor. Their forte was in concrete construction. They did an excellent job constructing the 3 AGS reactors, and turned out to be a great project in the end because of that. And then Aqua Narita themselves, as far as the support and the expertise that they provide and continue to provide to this day for us in operating this brand new plant has been extremely helpful. So.
Yeah. Lee, you got a big pat on the back there from Tony. Anyone that you want to shout out as well?
Yeah, and it was not a one-man show, and I'll tell you what. We had Tony, both Tonys. We have Tony Schachle and Tony Darling, both in our operations department. Without the operators, none of this stuff can happen. And they bought in, they pitched in, and they lent a big hand and gave lots of great feedback as far as we went through the process and selecting equipment. They really helped us out. I'd also like to give a shout out to Automation Control Service, our integrator. Without them, we would not have made it. And I would really like to tell them how much I appreciate it. And also the people that helped design this process is game changing. It's new innovation. The folks at TU Delft in the Netherlands that designed the granular sludge process in the university settings. Without the universities in this world, we would be mired in tradition. And it's just wonderful that we have this technology to take advantage of, to save energy and to save our valuable resources.
Well, thank you guys both so much. For anyone who's interested, we'll have the articles linked below for all the top projects. Definitely check out last week's top projects video, which is also linked down there, and we have a whole playlist on there as well. So check out all of that information. And to Tony and Lee here, thank you so much for talking with us. And I loved learning a lot more about this AGS process. That sounds fascinating, and I want to go read more.
Thanks for having us, Bob. We enjoyed it. Thank you.
Yeah, it was great. Thanks.